Hi, welcome to my next video. This is me making a time-lapse rig for my TiVo Tornado. A time-lapse rig on a 3D printer means that it takes a photo, you move the print head out of the way, it takes a photo of each layer so the print looks like it's morphing out of the print bed without, as you can see here, the print head flickering around over the print all the time. I'm going to use a Hall sensor which is fired by a magnet, so when the magnet passes in front it will trigger the Hall sensor. I'll use an Arduino Nano. That then will trigger a relay which will fire the shutter on the camera. So this is me making the parts and testing it. I'm not going to redesign the wheel. I'm going to download some of the parts like the fan mount and just modify it so it does what I want it to do. And then we'll give it a test and see what it looks like. So I'm going to have a quick look on the internet on my mini factory, see if anybody's got a fan mount I can use. In fact, I think I'll just search for a time-lapse rig and see what comes up. This is the great thing with 3D printing, people share their files. Yeah, there's two rigs and one's for the ender. Perfect. Now, this is how a lot of people do it. I don't like this idea of pushing against the button because the printer is quite precise and you could damage it. So I'm just going to use the fan mount and redesign it here so that it can hold an arm with a magnet on it. So when the head goes out of the way and moves to the right, it passes the Hall sensor and fires the camera. 3D printing is brilliant. Everybody shares their files. Most of it's common license. So I'll put the link to his original parts because somebody might want to use the same thing on their render. But you can redesign everything. You can make it do what you want it to do. You can re-upload it if you want to so other people can use it. I did that with a bed leveling system for a iPrusa 3 that I had years ago. The videos are on my YouTube channel, I think. And this is just the arm that's going to hold the magnet that moves back and forth. I also need to make a block to go on the end of the Z-axis to hold the Hall sensor because there's some bolts and heads there. So I need to make something to fit over them that I can screw to the printer. And yeah, 3D is brilliant. You can print anything you want. At the very end I'll show a part. A guy in work broke a roller blind insert and asked if I could print another one. A little bit of time redesigning it and then print it, and it's an exact copy that will fit in the blind and the blind will work just as well. And you know, you can just do anything you want with it as long as you've got the imagination. Or you can get a good website is Thingiverse. Even if you don't do 3D printing or CNC or design, having a look on Thingiverse and seeing what people have actually designed and upload for anybody to use is quite impressive. So this is just the block I'm designing to go on the end of the Z-axis to hold the Hall sensor. I was going to make it square, but then decided to make it as an oval. Looks a bit nicer. Nothing special, just a block with 3 holes so that I can screw 2 onto the printer and one fits over the head of the pulley. And I'm just using 3D Builder, Microsoft's built-in 3D program in Microsoft. If I use Fusion 360, I'm not brilliant with it yet. I'm still learning it, and it would take too long and be a 20-minute film. I'll also have to make a cable for the camera. I'm lucky the camera I'm going to use for this has got a port for an interval meter, where you can do time-lapse by setting how often it should fire, how many shots, all that kind of stuff. It uses a 2.5mm mini stereo jack plug. It's got 3 wires. 1 wire is ground, 1 wire is focus, and 1 wire is fire the shutter. So once I've designed all the parts, I use a program called Simplify 3D. The model I've saved is an STL file, stereolithographic file. You load that into this program, you tell it what kind of resolution you want, how many outer skins, how much infill, if it needs support. This is where you can also, there's a scripts tab, and in there is where you can put in the G code that you need to make it fire the camera. That was the layer change tab there. So you just load your parts in, line them up where you want them, tell the program all the parameters you want, and then it slices it into each layer at the thickness of the layer. I'm using 0.04 mil, and it produces a G-code file, and the G-code is then passed to the printer. It understands G-code is just a set of coordinates and how to retract, move, where to put filament. It's used quite a lot for CNC, 3D printing, a lot of stuff, laser cutters. So once I save the file, I print them out, and here they are printed. 3D printers are brilliant. You know, you can replace stuff, make stuff, design stuff. They're just excellent things. So I'm just screwing everything on here, and then I'll do some checks just to make sure everything passes it and it's going to be in the right place and at the right height. And then we'll have a look at the electronics. Like I said, I'm using a Hall sensor, a relay, an Arduino Nano, and that's it really. 2 pins on the Arduino. So that's everything fitted and working, and here's the electronics. So Arduino Nano, Hall sensor, relay. I put the magnet, that's what passes the little black bit on top of the Hall sensor. They all get 5 volts, they're all ground, and then you got the signal wire for the relay, and you got the signal wire for the Hall sensor. That's it. So then we'll put the sketch together. So I'm going to write the script. I'm not brilliant at this. I'm starting to get my head round Arduino and learning to do it. So first of all, you define the pins and give them a name. So it's pin 10, pin 3. I've called it Hall sensor and relay. Then you define what the pins do. One's an input, one's an output. So the Hall sensor is an input, the relay's an output. And then in the loop, you just put what you wanted to do. So it digital reads the Hall sensor. If the Hall sensor is high, it delays it for 1 second. Then it makes the relay go low, which closes the connection, and the camera will take a picture. Then it goes that if the digital read is low, don't fire the relay, which means it's not taking a picture. That's it. It's the most basic code ever. It's just if, then, if, then. So I got to save it and realize my typing is awful. And it fails because I forgot to put a bracket on a double bracket, and I spelled relay as really or reality. Fix those issues, and now it's time to start putting the G-code script into the layer change tab. I start with a G90 command, which is absolute positioning, i.e. it adds what I'm doing to from where it is, not from 0. That's as far as I understand it. Then G1, which is a move command. Feed rate is 9000. I've already measured it, so I move it X 305. That's the print head, and the bed 300 comes out to be in front of the camera. I tell it to wait for 2 seconds while it takes the picture. I think 2000 is 2 seconds. In G-code it might be longer, but it doesn't matter. That just makes the print longer. And then it will just go back to what it was doing. It will move the print head back to the position it was in and carry on with the print. I save this as a new profile for the printer, so I can print normally or I can print as time-lapse. And hopefully that's all I need to do. Same again with everything I do. I'm not an expert at G-code. I had to look up the absolute positioning thing. I wasn't sure. The rest of it is just standard code that G-code uses. F, X, Y, Z, they're all different things. And save it, and then we'll give it a try. And hopefully it will work. But first I need to make the lead and put it all together, and then we'll see what the print looks like. And now I'll make the cable for the camera. Pretty simple, it's just soldering up a 2.5mm stereo jack plug. Tin the wires first, stick them on the plug, and then we'll give it a test just to make sure it fires the camera. That's the port on the camera. Most cameras nowadays have and that's it, touch the wires, and it's the same as pressing the shutter button on the camera. So I'm just tidying the wires up here. But my other cameras use infrared, so I might put an infrared emitter on the Nano so I can use other cameras as well. I just hot glued the Hall sensor onto the mount. once I knew exactly what position to put it in. This didn't work out too well because the printer's hot and the glue got soft and the Hall sensor fell off, so I ended up screwing it on. Electronics are still just on the breadboard, and this is just testing that the camera fires, which it does. You can see the red light going on the Hall sensor to say it's been triggered, and this is my first test, and it works. It just took a photo, and after the next layer takes a photo as well. So here's the first print test I tried. It's hand solo in carbonite. It worked really well, but there's a little glitch. It's not brilliant. It's my first time. I wasn't sure where to put the camera, what angle, but you see the glitch here, and I couldn't work out what it was at first, but then I realized it didn't completely finish filming the print, and as the print head was going up, it was pulling one of the wires off the Hall sensor, which was causing it to trigger sometimes. So I tried it again with another 3D print, which is the vase that you saw me printing on my new printer last video, and this one worked perfectly. So all I need to do now is solder it all up, put it in a nice box and set it up so it can sit on the printer and I can use it whenever I want to. This is what I mean about 3D printing. This is the original roller blind part that my mate in work has lost, one of them, and this is the 3D printed copy. I just measured and remade the original part, printed it out. Oops. It's not exactly the same dimensions for each part, but it's the same size overall. So all the splines line up. They're the same thickness. It should just slip straight into the cardboard tube. And the only bit that you could tell it's the 3D printed one is the roughness, because I had to use support material. 3D printers are brilliant. And that's a solid plastic part, the same as the original part. So I'll give him that tomorrow and he can try fitting it. If it's slightly too big, I can just print another one slightly reduced in size. Anyway, thanks for watching.